6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. 7.5 pounds of thrust, and it has cleared the tower.
Prepare yourself for a world of consciousness. This is
Good morning, everybody. Conley here, KVLF. It is the Science Nights in the morning, just after 10 o'clock. And you know what? We have all the knights assembled. Dr. Anirban Bhattacharjee in the house here. And we also have Dr. Thomas Shiller, all the way from Australia, down under, Sean Dram. What's up, Sean?
Hey, guys. What's happening?
Not much. Just recovering from Thanksgiving. Still digesting pounds and pounds of turkey and dressing and all that good stuff. So I might fall asleep at some point during this.
Yeah, turkey is like the Ambien of any kind of dinner plate.
Yeah, that's total BS.
That's a myth, by the way. I was going to say,
I don't know.
Yeah, they say it's the tryptophan in the turkey that makes you go to sleep. There's very little tryptophan in turkey.
Well, when you stuff it full of ZQuil before you put it in.
That might be the problem, yeah.
I think so.
Yeah, it's the other stuff that you eat that's full of tryptophan. Anything that's got dairy or anything like that.
Well, there you go. We figured it out.
So that's what we're talking about today. We're talking about tryptophan, right?
No. I think we're talking about
the deep sleep.
Deep sleep.
Deep sleep.
I've been having a few of those after that turkey.
Yeah, or deep sea.
Deep sea is what we're talking about.
Deep
So now let me offer a confession to everybody here.
Oh my God, Conley, are you going to say something?
I am going to say something. I'm going to say. I'm terrified of the ocean. I am terrified because it's the unknown. It's so hard to explore.
I thought you were going to finally tell us that you loved us.
Yes. I mean, that hates in your eyes, Conley.
I do.
Yeah,
I do love y'all. Yeah. I do love you.
You know the word for that?
What?
The fear of...
Being scared of the ocean?
Yeah.
What?
Thalassophobia.
Oh, really?
Oh, yeah. Deep waters. That's the actual fear.
Well, I mean, I'm not I wouldn't be scared like swimming in it or like, deep diving. I really wouldn't be scared being out in it. But what I am scared of is like what might be lurking underneath. There's a terrifying image I've had in my memory of like a small boat with this giant, huge thing coming underneath it. And you just don't know what it is. Mm-hmm. It's like, whoa. I mean, that could be anywhere when you're in the ocean. It's terrifying.
Yeah, there is some terrifying stuff out in the ocean. I'm sure Sean will tell us all about that. But we've had probably half a dozen episodes where we talk about the scary stuff that's lived in the oceans throughout the past, 400 million years.
But if the recollection is true or so, but the things that are in the deep sea, here's a great part. Mm-hmm. I'm not going to come out to this ocean surface to attack Conley. That we can guarantee because they would most probably not survive up in the surface. Am I not saying the truth here, Sean? Like the one that is...
That's right. Yeah. So some of them, the deeper you go, a lot of these deep sea fishes are so adapted to super, high pressure environments of the deep ocean that they can't even make it to the surface without the pressure differential killing them. So it would require Conley to go down deep.
Yeah.
Does that sound good, Conley? You want to go down to
I'll give it a
25,000 feet below and see what's down there that can pull you apart.
I'll make you a deal. As long as I can see some aliens, I'm cool.
They all look like aliens down there.
They will look like aliens.
So how far does light go down into the ocean? Like how deep does it go?
So the deepest,
all the way to the bottom.
Yeah, I mean, all the way. I was going to say the deepest is the Mariana Trench, right? 11.2 kilometers. So that would be the deepest.
Yeah. Challenger
what's that in feet for all of us West Texans who don't know about kilometers?
A gazillion, trizillion, quadrillion feet?
Yeah.
Is that what it is?
It's deeper than Mount Everest is high.
Yeah,
which is pretty impressive.
35,000 feet, give or take. Yeah. And that's taller, that's deeper than Mount Everest.
Yeah, that's the height where like jet planes fly, like 30 to 36,000.
Yeah.
So
pretty crazy, dude.
Yeah.
So what's that in miles?
8 miles, I think.
8 miles.
Yeah.
Wow.
Yeah.
Golly. See, I would think that the ocean would be a lot deeper, frankly, but okay, cool. 8 miles. But
that's
impressed.
Yeah.
He's not impressed.
At all.
So let me try to impress you more. It is said, like I think both Thomas and Sean will back me up on this, is that we know more about moon than we know about the underneath what lies in the ocean floor. Am I not right on that? Like that's what I've read.
That's been said. I think the phrase is that we know more about the surface of the moon than we know about what's on the bottom of the ocean floor. Yeah. I think we've mapped the ocean floor real well, so that phrase might be kind of dated in that respect. But it is true that we haven't sampled very well the bottom in terms of the life forms that are there. We have very little, occasionally we get good footage of this stuff from submersibles going down, but it's poorly known. That part's still true. There's nothing alive on the moon's surface, so in that respect, it's not really true. But it's still, I think it still holds, which is pretty interesting. I'll bet they used to say that probably back when the ocean floor was not even mapped, and now it is. Yeah, but it still kind of rings true.
Yeah, around the early 1900s, and this is kind of rooted in the foundation of science fiction, if you really look at what was being written back then. And I'm deviating a little bit from the actual science here, but if you look at the novels and the sort of, serials and short stories that were published back then, everyone was curious and terrified about what was in the deep parts of the ocean. And they still really are. Mm-hmm. I think mainly about the biology, the things that are living down there. But so if you go to Google Earth, free software that you can download and play around with, they have the surface mapped out in 3 dimensions on Google Earth. You can dive beneath the surface of the ocean and see all of the major trenches, the mid-ocean ridges, everything.
So as for what you're saying, the geology is pretty well mapped out, right? But what is not mapped out is the life that we find there. We don't really know much about it. And so if we step back a little, what I know from my rudimentary knowledge of geology and biology, there are like 3 layers of the ocean. You have the mesopelagic or something, which is the top layer. And then you have another layer, and then you have the lowermost layer of the ocean.
the bathyal, the abyssal, and the hadial.
Whoa, Hades? All the way down to Hades?
Yeah, that's way, way down there. That's, I can't remember where the cut. I think it might be 8,000 feet, something like that. But
is that where like the four horsemen?
That's where Cthulhu hangs out.
8,000 meters. Oh, meters, not feet.
Yeah, 8,000 meters.
Lovecraftian on us.
Yeah, but these are all depth determined sort of levels, and we use them sometimes in geology, but they're mainly used in sort of oceanographic study, really, because they have to do with depth, not necessarily the physiography or the bathymetry, the term we use for the ocean floor. We talk about them quite a bit as we relate them to kind of biology or paleobiology, where different organisms will live. The main reason in just kind of general geology that we talk about the different depth horizons is because we have a kind of threshold that we call the CCD at a certain depth, ranging between 5,000, 6,000 feet, where below that level, calcium carbonate will dissolve.
Okay.
So it affects how deposition happens, basically. But, to kind of introduce the deep sea setting that we're going to be talking about, it's kind of important to discuss kind of the broader picture, I think. And geology has a lot to do with that, specifically tectonics, plate tectonics. And I'm not going to spend too much time on this because we've covered it. Yeah, we've done a whole show. Yeah, multiple times. But really the shape and the form of the ocean floor has a lot to do with how the tectonic plates are interacting and how they're moving. At certain places, the plates are rifting apart, they're spreading apart. At certain places, they're colliding. At certain places, they're moving against each other. And all of those different scenarios kind of facilitate different geomorphic features on the ocean floor. So when you push two plates together, you drive up the surface rocks. When you pull them apart, you create valleys, you create rifts. And all of this is happening both on the continents and beneath the surface of the ocean.
When they get pulled apart, does the ocean, like, technically, quote unquote, get a lot deeper? Or they're undiscovered? I mean, of course, there'd be undiscovered places, but would that be deeper than you'd say normal?
Funny enough, it's not where they're pulling apart that it's becoming deeper. It's where they're colliding. Really? So where you have a spreading center is what we call it, like at the mid-oceanic ridge, like the mid-Atlantic ridge.
Right.
You're essentially having new rock forming kind of constantly, forcing the tectonic plates away from each other. So it's this kind of recycling process. You're not removing rock, you're not adding rock kind of to build it up. It's not accumulating, but it's just forcing the plates apart kind of like a conveyor. Now where you make the ocean progressively deeper are at subduction zones, where you have usually a oceanic plate, so the thin oceanic crust, either diving beneath another body of oceanic crust or a body of continental crust. When it comes to the Marianas Trench, the deepest part of the world, you have a piece of oceanic crust that's diving beneath another piece of oceanic crust. And as it's doing so, it's kind of pulling down the other tectonic plate.
And what you're doing with your hands, you're kind of like, making a little downward.
Yeah, I'm making
a little heart.
Little heart, yeah.
A little heart. But that's kind of, how this is described. So for our listeners, could you say that there's a whole different universe under the ocean that kind of resembles the mountain ranges we see on top of the?
It's pretty different, and the reason is because of the nature of the oceanic crust. When we look at the tectonic plates, we have plates that are roofed by continental crust in part, and parts of the plates that are roofed by oceanic crust. Huh. And again, this is something we've talked about several times, so I'll be real quick about it, but the continental crust is thicker and it's less dense. The oceanic crust is much thinner and more dense. It's made out of a different type of rock. So when you have two oceanic plates collide, or an oceanic and a continental plate collide, one of those plates tends to dip beneath the other. When it's a continent to an oceanic plate, the oceanic plate, because it's denser, is gonna dip beneath the continental plate.
Yeah.
And different things happen. Generally speaking, what happens is volcanism, because you're taking a plate and you're driving it deep within the earth where temperature is increased.
A lot of friction.
Yeah. Well, there's friction. There's all sorts of processes. You've got fluids. You've got interaction with fluids. You have depth and pressure and all these factors.
Yeah.
But ultimately what it does is it generates heat and molten rock that will rise up to the surface and erupt. So in the case where you have an oceanic plate subducting beneath a continental plate, that generates volcanoes on the continent. Where you have an oceanic plate collide beneath and subduct beneath another oceanic plate, you have volcanoes that are out in the middle of the ocean. You get what's called a volcanic island arc.
Wow.
Like what you see in Indonesia, like Java, Sumatra, and places like that.
Yeah, and I noticed you're still making a heart with your hands. Are you trying to tell me something?
It's hard. Yeah, it's hard to describe these things without doing sign language and writing things on the board. But
lots of expression.
Yeah, if we have our hardcore Science Nights listeners, they've heard me jabber about this 100 times.
So and as this thing is subducting and everything, one thing I think Sean will also come back to this later about the life forms. There's magma being released, right? So like this is like magma, like hot magma coming out. So keep that in mind. We will talk about that, I assume, in that. So so the main thing for the physics point of view is what is interesting as you keep going down. The pressure increases, right? So you have the amount of water keeps on increasing on top of you. So I think the rule of thumb is, I think you descend every 10 meters, you have 10 or 20 meters, I believe, 1 atmosphere kind of worth of pressure increases. I don't know exact one, but by the time you're down in the bottom of the ocean floor, like in that kind of like 10,000 meter level, the pressure is over 1,000 times what we feel, 1,000 times what we
and
feel here.
And this is coming from all directions, on
all surfaces. All surfaces.
Yeah, so, hydrostatic pressure.
So it's not just from the top you're feeling; it's going to be crushing you from all sides.
Wow.
So, and I think we will also go over some missions. So, which now this kind of illustrates the point, is like why, like if you're going to like send a manned or an unmanned mission, that's why we say this is still a mystery, is because doing at that level, surviving a pressure of that, you need to be highly specialized to do your equipment. So your equipment needs to be highly specialized. So to survive that amount of pressure, because
you got to be able to hold your breath for a long, long time too.
And yeah, so need really long time. Yeah. Those special lungs, I guess. Yeah. So
I'll give it a shot.
Yeah. Okay. All right.
Okay.
And go. And he's dead. He's dead. All right.
I saw Cthulhu, guys.
Yes. So that happens, and so it's pretty hard. So you have to be specialized. And another thing is very interesting that I found out as I was looking at, it's like over the zone of this deep sea, things are overall very uniform. It doesn't like change like for example, the ocean water is not going to change a whole lot over like 1,000 or 2,000 meters. The amount of salt in that water, the temperature is not going to change a whole lot, and the light overall is going to remain the same. So the conditions that you're looking at is going to be uniform throughout the world. It's not like it's going to see a huge like a variety. Yes, you're going to see a geomorphological variety, sure, but overall the physical, there's not going to be any physical differences from places to places. So what it gives you is this interesting thing is if you notice something out, like not something that's very radically different or even a little bit different, then it will become something weird is going on there. So you might want to go check it out at that level, what is going to happen. So otherwise, yeah. So, it's also because the first thing is like the temperature is pretty uniform because no light reaches down there. So there's no light. No light.
Well, okay, wait. Here's a question, though. But when you get to a certain level, I guess biology of the deep, deep ocean, they start producing their own light, right?
Some do, some don't.
Yeah, but some do.
Yeah, some do. Bioluminescence, yes.
Yeah, that's pretty cool. And so the biology is creating a form of light that would kind of affect things like the sun wouldn't, right?
I'll allow Sean to take over, but what I was going to say, bioluminescence is not because it's down below in the deep sea. We have organisms up in the ocean level and on the surface which produce bioluminescence, right? You have fireflies and stuff like that which have that.
Sure.
So it's not that they are, they are deep sea. There's no light to produce bioluminescence, but that is not the only reason they will have that. That's one of them. Am I not right? Since saying that, Sean?
You're right. You're right in saying that bioluminescence isn't peculiar to the non-light zone. Down in the deep sea, because it does turn up on the surface, like you said. It is something that you notice, and it is pretty common in these zones. And one thing that's really interesting is I always thought was cool about bioluminescence is that it's not actually produced by the fish itself. It's produced by microorganisms that the fish is carrying around in specialized organs, which is just, and that goes for any bioluminescent organism you've ever heard of, from fireflies to anglerfish that use a little glowy object on a stalk to lure in prey. So those little organs, those photophores, have tiny little microorganisms that are capable of generating light, chemically, without producing corresponding levels of heat, which you usually would have, hand in hand.
That is so fascinating.
It's a symbiotic relationship between microorganisms and whatever the host organism is, almost like a parasitic relationship, except it benefits both, and so it therefore becomes mutualistic.
Yeah, it's very interesting I didn't know that fireflies also had microorganisms to produce light, and it's not by so like
Yeah, there's no, unlike, you can kind of think of another example of like, we've talked about electric fishes before, and they've got specialized organs that create, electrical discharges without heat, corresponding heat. But in this case, that's like a super highly modified muscle fiber that can do that. In this case, it's nothing like that. It's just like a little, vessel for these microorganisms, and it's the microorganisms that do the work.
And it's really kind of like a chemical reaction. We're about to head to a break, but this is so fascinating that we can look deep down in the earth and find and discover things like this, and it's like as above, so below almost.
Yep.
Hey everybody, it's Science Nights in the Morning. Sean Graham here, and we're talking about the deep sea. And where we left off, we were talking about bioluminescence. And, I want to talk a little bit about some of the other cool adaptations that fish in the deep sea have. And there's kind of three main areas where the deep sea fish kind of have their, like we were talking about the different zones and how they're kind of segregated by depth. The geologists talk about the mesopelagic, bathypelagic, and down to the abyssopelagic and Hadean zone, way down deep. And those zones are kind of defined oceanographically, also by how far light penetrates. And that kind of determines what kind of fish you're going to have. The mesopelagic zone is like the farthest limit where light can penetrate. Mm-hmm. They call it, the common names for these awesomely are like the twilight zone. And below about, 300 or 3,000 feet.
Meters or feet?
Yeah, I'm going to do feet so that people don't have to rush to their Google calculator. But below that, light doesn't penetrate, and it becomes like the midnight zone where it's constantly dark. And the fishes in that kind of mesopelagic zone are kind of really interesting because some of them will actually kind of float back and forth between the super dark zone, and then at night they actually will migrate. It's one of the most important migrations in life. It's this vertical migration from the twilight zone up into the zone where during the daytime there's actually light. This was really interesting. It was discovered that these fishes were doing this during World War II when they were starting to use sonar to map to the first maps of the ocean floor. And they were getting these crazy readings where at night the ocean floor would be a couple thousand feet higher than it was during the daytime. They discovered this deep sea sonar scatter zone where the sonar was getting scattered by something. It wasn't penetrating to the true seafloor. They were getting this phantom bottom, and they couldn't figure out what the hell was going on. And what they had discovered was this gigantic population of mesopelagic fish. And the sonar was bouncing off thousands and thousands and thousands and really, truly billions and trillions of individual little swim bladders of these fish. So they inflate their swim bladder. Most fish have a swim bladder. It's this like inflatable sac in their body cavity that allows them to maintain neutral buoyancy. Because what you don't want to do if you're a fish is spend all your time like fighting, trying to stay buoyant.
Well, hold on.
You know what that's like. You go in the swimming pool and you have to kind of tread water. Every time you breathe in, you're buoyant. Every time you breathe out, you're sinking. And fish have that same problem. If you're going to be neutrally buoyant, one of the adaptations you have is having this little inflatable sac.
Well, wait, hold on. How do they get the air to inflate that little bladder sac of theirs?
Isn't that funny? Yeah, it's physiologically. They pull it out of their own blood.
Oh,
yeah.
Cool.
So some of the advanced fishes can actually do this physiologically, where they essentially, their bloodstream has a remarkable kind of netting of capillaries where they can pull individual gas, molecules out of their blood and inflate the sac. Now, other fish can actually gulp air and inflate the sac directly. But of course, these fish can't do that because they're at 3,000, 4,000 feet. They're not going to go to the surface to gulp air. When you see like catfish doing that at your local pond, often that's what they're doing. They're gulping air to inflate their swim bladder. But these guys can just do it physiologically. And so they inflate this thing kind of slowly, and they migrate up. And during World War II, they're finding the sea bottom coming at them at night and then dropping again. This is one of the, and when Anirban was talking about the ocean floor kind of having a very similar conditions worldwide, similar temperatures, light penetration, nutrients, that means that this habitat is the largest habitat on Earth. Wow. Right? Mm-hmm. It's pretty static across the continents, across the ocean basins, and you have pretty much the same fish occurring across this habitat. This makes these fish the most abundant vertebrates on Earth. They don't even use the word trillions to describe how many there are. Mm-hmm. They use the word quadrillions.
Which is like...
I don't even know what that is.
So you have a billion,
1 billion million,
a million. No, it's a million.
Is it a million trillion?
No, it's a million billion.
Million billion.
Okay, million billion. Yeah,
these are not these are only terms we've heard on the playground.
Yes, exactly. I was having flashbacks to third grade
when we get beyond the triple dog dare.
Yeah, so we say billion billion.
These things you probably never heard of them. They're called. There's a couple of different kinds, but mostly it's the same like species across the world's oceans. The bristlemouths, and lanternfish.
Wow.
I'm assuming they're floating up there to feed off of plankton and stuff like that lives up in the photic.
That's
zone.
right. They're going up there to feed every night. They most of the deep sea fishes are feeding on, there's no photosynthesis going on down there, so there's no productivity, there's no plants.
Right.
So there's not like an ecosystem built on plants down there. Instead, they're all eating detritus. But these mesopelagic fish, since they migrate up into the zone where there is light penetration during the day, they're able to get at some of that food, some of that primary productivity that's produced by plankton during the daytime.
So I have to ask you, now we are talking, we just got finished doing third grade banter.
Yeah.
But if they're, inflating their little sac there, their bladder sac, do they excrete it at all?
Yeah, so they would have to, they inflate it at night to migrate up, and they do it passively. All they got to do is just they do waste energy because this process, the physiological process of kind of pulling gas out of their blood, doesn't cost nothing. But at least by all they got to do is inflate that swim bladder, and they'll just passively float upwards. And then all they got to do is deflate it to return.
And they just kind of toot in the water?
The deflation is probably easier than inflation, and it probably involves a burp or a fart.
Yeah. Well,
and that's what you were getting at?
That's kind of that's what I was getting at. But in all seriousness, though, when you're talking about the abundance of these tiny little organisms, wouldn't that affect some kind of pH level in the ocean or some kind of would that cause a dramatic environmental change?
The PU level.
Okay, yeah, I'm sure too.
I apologize, everyone. I've been hanging out with my dad over the past couple of days.
That was actually, I love that one. That was a good one. So these fishes are super important. Just the biomass of these fish, would take up a huge amount of various chemicals from the ocean.
And
so this would be just pure. It would be pretty much oxygen that they'd be excreting. It wouldn't be like methane and all that nasty stuff that we mammals excrete and larger vertebrates.
Yeah, I'm sure. Yeah, I'm just
that
talking
could oxygenate
about
the water essentially.
I think of it. I'm almost thinking about it in geological terms as this layer of like sequestered carbon and calcium and all that stuff. And if all these things just suddenly died, you would have all that released into the ocean. But I'm sure it's a heavy influence on nutrient cycling in the ocean.
Yeah, and that is an interesting point, because if they are in part feeding on detritus at lower levels, then they're sequestering carbon themselves, not allowing it to get to the seafloor.
And And I was going to say, on top of that, there is a lot of animals which feed on these fishes when they rise up. So as they're rising up,
that's right.
There's a lot.
It's a cool way to kind of transfer nutrients and primary productivity down to the lower levels. Because it's not just a steady rain of detritus down to the bottom. If it were that, it kind of wouldn't be as interesting, and it wouldn't support as much biomass. Instead, these guys are kind of transferring back and forth. And this is just the first zone. So if you go below that zone, you get kind of a slightly different crew that hover at these kind of intermediate depths that aren't quite as deep or as shallow. And these are some of these things you might have seen on like Planet Earth or the ocean documentaries. These are the ones that have like the bioluminescent lures. These are the fish that look real weird and flabby because they don't have to travel back and forth up to the shallow layer, so they just kind of remain hovering and kind of succumb to the pressures and just become these gelatinous blobs. And these are the fishes you see that have like the giant mouths.
Yeah, and the nose hanging over the mouth. Looks like a cartoon character.
Used to show up on the National Enquirer.
And shrimps. Like there are a lot of shrimps in that level too. So don't forget shrimps.
That's right. Yeah, I'm focusing here on fishes, but there's all these other invertebrates that live in the same kind of environment. But you get the anglerfish, the gulper eels, these things that can eat things larger than their own bodies, and then kind of store them and live off of those things for months because this might be the only meal they come across.
Wow.
And then the bottom fishes in the abyssal zone again become kind of more straightforward, stronger with a tighter skeleton, living in deep pressures. And they're going to be feeding on just the the stuff that does rain down, right? They're not, and a lot of times these are going to be just feeding strictly on detritus. The premium here is on detecting prey in a very low light environment where they're not seeing much food. So in these cases, you'll get these fishes that have, they in many cases, they look a lot like blind cave fish. They don't have eyes at all. And they have their lateral line system, which can detect vibrations in the water, will be some of the most best developed of any fish. In some cases, the lateral line organs are actually on little bitty stalks that stick up off of the skin so that they can really just any kind of movement down there, they can detect and try to go and eat something that's moving.
Yeah, wow. I think another cool thing about all this, from a historical sort of standpoint, not ancient history or anything, but until the technology was developed, the submersibles that people could actually delve down into these depths, we had very little clue as to what was down there. And I think occasionally one of these really bizarre fishes or something would wash up on the beach. And if you can imagine, when you look at these things, I'm sure everyone listening has at least seen one of these documentaries that Sean mentioned. They're really, really bizarre, alien-looking things. And if you could put yourself...
Describe it.
Well, at the kind of moderate depths, you have things with gigantic eyes, that are trying to take in as much light as possible, things that, their eyes are 25% of the surface of their body and weird stuff like that.
Yeah.
And then these things that are essentially blind and that live at greater depth. Things that you don't see, you're not going to pull up on.
And they have really long, kind of sensors all over,
they're alien-looking things.
Yeah, yeah.
Now I was just imagining
that's in the abyssal zone.
Yeah, that's at really deep and great depth.
And you have some of those weird-looking fishes which have huge mouth. So some of those are in there.
So some of the ones that you should, I would like to mention. There's some that use bioluminescence near the eyes that actually project light directionally that are called flashlight fishes. And they use them to like you would use a flashlight to search around for prey. It's amazing.
It's kind of a signal, though, wouldn't it be a signal? And wouldn't
well, in some cases, yeah. In a lot of cases, they're just using them for signaling. They can use them for camouflage. So a lot of them have the photophores on the bottom of their belly, so that fish looking up get confused and they see the light and they just kind of think it's the light of the surface instead of the fish.
Wow.
So it actually disguises the fish. Some use them for sexual selection. They make little species-specific, flashing to attract mates. But a lot of times, I mean, the flashlight fishes are actually using it like a searchlight, which is just nuts. Here's another one. The brown snout spookfish has 2 pairs of eyes.
2 pairs.
It's two pairs. It's evolved 2 pairs of eyes. One more or less from scratch, where it has a pair of eyes on the top of its head, and a pair of eyes looking straight down, and it can see up and down simultaneously.
There's not a single other thing that I can think of that's evolved 2 eyes. That's
not from scratch.
Vertebrate, yeah.
Not from scratch, because there are, there are some where the eye has become kind of split in half to look up and down on the water surface. And so, whirligig beetles that you've seen swimming around, swamps or even, desert pools, those guys have 2 pairs of eyes, but you can kind of see how they evolved them from an eye that basically split in half and migrated. And there's a fish that has kind of split pupils like that for seeing above and below the surface film of the water. But this thing has essentially built a second pair of eyes from scratch, from nothing.
Yeah.
And one eye can look up, and one eye look down, and one of them is kind of specialized for detecting bioluminescence. So it's just off the chain.
It's similar to like if you take just like a regular fish, like a rainbow trout, like a trout or something, and you put giant Gucci glasses on it, and it it raises it up above its like on its forehead, and that's kind of what the spookfish looks like. It looks like it has a giant pair of Gucci looking sunglasses on its forehead, and then it has the little eyes underneath. Really cool, really interesting.
And I think Anirban would have a better chance at explaining how, you can tell it's one set is completely different from the other, because the way that it uses light is totally different than pretty much any other vertebrate eye. Like it acts like a pinhole camera, and my eyes start glazing over whenever I look at these kind of physical explanations of how light is focused and that sort of thing. I'm like, what is going on? But anyway, it works. It focuses light totally differently than any other vertebrate eye. And that gives you the clue that this thing is kind of brand new under the sun.
Yeah, this is I never knew of this fish at all. It's just, it seems like it has very interesting eyes. And I was just looking at it. And it uses them. First of all, it's going to use like a lens which normally every eye does it.
Right.
To
That's
focus,
the usual way.
Yeah, usual way. And then it has a secondary eye which does not use a lens to do it. It uses
that's the pinhole camera. And of course, when you say pinhole camera in 1935, everyone would know what you're talking about.
Yeah, and then
I don't know what a pinhole camera is. And how it works.
Yeah, and there's like crystals which will reflect the light back and stuff. So it will use that. And what I'm more surprised is this is not like compound eyes in insects, right? This is nothing to do with that. And it's just how would they process when the image comes into that's amazing to me.
The processing part, I think I could get my head around, because it would work almost like pit vipers. Pit vipers have regular eyes, and then they have the pit organ, which receives infrared information.
Okay.
And then both of those sources of information end up projecting to the exact same part of the brain, the optic tectum. And that part of the brain processes them simultaneously, so it gives you an overlapping infrared visual image. I would give you. I would tell you probably this is the same thing that's happening here.
So it's not
the image that this brain is figuring is not like, oh, I got to look up first, then down first.
No. I'm not.
I wonder what's up. No. It's like at the same time this fish is experiencing up and down.
That's what I'm saying. It's for us, it's as if you're seeing the sky and the ground at the same time, right? That's what the fish would be seeing.
So I'm gonna call an audible. We're about to go into a commercial break. What happens when this thing starts daydreaming?
Yeah, mull that over, listeners.
Think about that. If it's daydreaming and it's seeing two things at the same, that's just
Here,
a complete conundrum.
I've got the answer to that question. It doesn't know what day is. So
Okay, there you go.
it's just dreaming.
It's just a dreamer. It's just a dreamer.
lonely dreamer.
Well, we're about to go to another commercial break. Now, when we come back, old Conley is going to be putting on the metallic helmet.
Thought you were going to say Metallica helmet.
We're gonna dive all the way down. We're gonna try to reach Hades. Let's go after the break. All right, everybody, we are back. Well, all right, just imagine something. We've been talking about the ocean floor, the deep sea level, and the environment, the organisms that live in this deep sea. Now, just imagine being on the top of the water. Your boy Conley up there. I'm screwing on this metallic, the old time metallic helmet that has like the cage.
Helmet,
It's a diving helmet, but it has like the cage, and it's all metal and it's huge. And so I got that on. I got my skin tight Speedos on, and I am like playing with the dolphins at the top level. Okay, where we're diving deep.
You've put a lot of thought into this imagery, haven't you, Conley?
I think I'm getting over my fear.
Okay,
I'm getting over my fear. I'm challenging it. I'm going deep. I'm starting to see the spookfish now. We're at the
you would have
level.
already imploded.
Yeah, I'm in VR.
Okay, you're VR. Okay,
VR.
Okay.
And I'm seeing the spookfish. We're in the abyssal level, right? Okay. Now, where's Hades? At what point do I start seeing the Hades level?
So, yeah, you get down into the Hadal zone as you get into like the ocean trenches, way, way, way deep. And I don't know. I know very little about the biology. I don't know if anyone knows a lot about the biology because
that's exactly the point. Nobody, because the number of missions done to those ocean floors, like manned or unmanned, is very few.
Wow.
It's you can count on the number of hands. If I'm not mistaken, Sean, Thomas, right?
Do we know what the pressure is like when you get down to
it's like over 1,000 times the pressure that we face on the surface of the Earth. So it's immense.
The temperature is decreasing.
But it's still 0 degrees Celsius or somewhere around that. It's still cold, but the water is not frozen, right? It's still moving around. Water freezes at a much higher temperature, much lower. When you increase the pressure, it will freeze at a lower temperature. So it will freeze at a lower temperature.
So we don't know really. There's still a lot of mystery.
I mean, we've been there, and there are. It would be really expensive for anybody to do a ton of research down there. It does get done, but it's expensive. It's the kind of stuff that you need some serious grant money. And we should give a shout out to the first expedition that got down there.
I love the name.
What was this?
I love the name of that person.
Not Jacques Cousteau?
No.
Oh.
You will love it even more.
Elon Musk?
No. Jacques Picard.
Picard?
Yes.
Really?
Or did you have somebody, are you talking about Ross? Which one are you talking about?
No, that's the one. Yeah, the Trieste.
Yeah.
They went to the bottom of the Mariana in what,
60s.
Yeah, I want to say it was before Everest was climbed.
1960.
They went to the bottom.
1960. Everest.
That might be. Yeah. It's right around the same time. It's kind of the heady days of exploration, like the last gasp of exploration. The Everest was climbed, and they made it to the bottom of the Mariana around the same time period. Built, it's just a tin can that can withstand the pressure, and they went down there. It's pretty great. But
I bet Jacques Cousteau was pissed.
They go down to depths like that, and they get the cool stuff they're getting now is a lot of, we've collected some of the fish that live down there, but you just have no idea what their lifestyles are like. Because they come up from the ocean, they're
already dead
from they're dead from the pressure. So you never see what these things are up to, and that's kind of the final frontier, is getting videography of these animals alive. And that's the kind of stuff they're getting now. And every now and then you'll see these great quality videos of these ghostly images of some of these deep sea fishes and other invertebrates in the habitat doing their thing. And that's the kind of thing you can look forward to for the next 30, 50 years.
Wow.
Is the first footage of this beast doing this or maybe the discovery of something really phenomenal. I'm kind of holding out hope that there could be a living ostracoderm at the bottom of the ocean.
Okay, what is a ostracoderm?
Yeah, these are plated bony fishes that
they can withstand the pressure?
Potentially, yeah.
Well, they've been extinct for what, since the Devonian?
Yeah,
so it's a super long shot. These are jawless fishes that would be some of the earliest of our ancestors.
Devonian would be what, like 250 million years ago? 300 million?
No, that's Devonian. I can't remember. I'm not a geologist.
Okay.
He's not a numbers guy.
He's not a
numbers get mixed up.
I typically remember that being on a test, though.
Yeah, it's like 350, 400 million.
Yeah,
it would be like one of the most incredible living fossils ever found. Okay. It would beat anything that's been found yet. But you never know.
Mm-hmm. Yeah, no,
I think, isn't James Cameron funding a lot of this deep sea research?
James Cameron is into this stuff. I want to say James Cameron has been to the Challenger Deep.
Yes, 2012.
Really?
Yeah, even there. Yeah, he loves the deep because his movie.
He did that movie, The Abyss.
Abyss,
right?
That's right.
So that's what's down there. That amorphous blob of mercury or whatever.
A big city state of underwater aliens. That's all that's down there.
And
here's the real kicker for me. Sorry to interrupt, Anirban, but this is how I think about things. We have this snapshot of recent history and biology, but when I think of things in deep geologic time, fish have been around for a long time. And I always just wonder, and this keeps me up at night, really, is how much was living in these environments throughout the past 500 million years. Because there's weird stuff living down there now. Imagine what evolved over the course of that time and was living, because there was weird stuff like Sean was describing in the Devonian that was living at shallow depth. And it's just
underneath,
it's one of those things I think about.
And most chances are very high we won't even know ever.
Nope.
Yeah, chances are
nope. That's what curses my dreams.
And one of the things we should touch upon is, why are these explorations that important for us? Let's not even forget and say, it doesn't, what's the point in knowing this stuff? So one of the things we have to talk about is underneath, really deep down. So pressures are extremely high, and there have been and we talked about all kind of organisms, since we have found microorganisms and stuff like that near the hydrothermal vents where the temperature rises up and there is no light coming out and there is hydrogen sulfide gas coming out. So the temperature is kind of high, but the pressure is extremely high too. So in that kind of conditions, we have life surviving. And one of the proteins in our body, like actin and stuff like that, they behave very differently than what we have. In our own bodies. And again, in the organisms down below, we do not. What we don't have is unsaturated fats in their body. What they have is saturated fats, so that it can stay liquid for a long period of time. So there are a lot of things that changes how the behavior of protein changes, how an animal evolves. Now, why am I saying all this? Because this gives us a clue that life can evolve in the harshest possible conditions that we cannot even think of surviving, where we cannot. So these kind of animals are called extremophiles. And this gives us research, an idea, can life survive in other places which is not on Earth, by studying them. And so this is one of the main key reasons is how extreme can we take our conditions can be. Make the condition.
One of those extremophiles, it wasn't a deep sea critter, but one of those extremophiles had incredible biomedical application. So an extremophile bacteria found in hydrothermal vents, well, not hydrothermal vents, but hot springs in Yellowstone. And it enables us to rapidly sequence DNA. There's a process by which you heat and cool samples quickly, and the DNA comes apart when it's hot and then comes back together when it cools. And if you have an enzyme that can reestablish the DNA, double helix under the hot conditions, you can do this crazy process called polymerase chain reaction, which is something that they use. We've talked about it before. It's what enables you to test for COVID so fast. I mean, it's all over the place. Every lab in the country that works on DNA uses this technique. It's worth billions, and it's you can do it because of this enzyme found in the bacteria from the Yellowstone hot springs that is stable at temperatures that normally would boil any enzyme like that to bits.
I mean, it will boil a human being alive, pretty much. It's not like
it would parboil you, and yet these bacteria can function at that temperature, and you can take that enzyme and use it for biotechnology, and literally it's worth billions. That technology has made fortunes. So it's actually worth money.
It's very romantic to think that Mother Nature and the universal theory of biology has answered a lot of the questions that humans really desire to find out. It's this Pandora box that's trapped underneath the deep, dark unknown that is.
Well, it might help us answer the biggest question of all: where did we come from?
Oh yeah.
This is all. Wow. It's all has to do with theories on the origin of life and amino acids too.
My gosh.
Because you're looking at temperatures when Earth was formed, right? You're looking at extremely hot environment, extremely acidic environment. A lot of you don't have free oxygen, so there is no photosynthesis happening, and there's a lot of clouds and everything. So sunlight's not really coming through at all. So there's very extreme conditions, and still we have life. Like within 400 million years, life is there on Earth in terms of bacteria and stuff. So at that time, Earth was still not very stable. So life did survive. So
Well, don't we share DNA with some organisms that live inside of volcanoes? I remember reading a study about that.
we share DNA with pretty much any kind of living organism.
Yeah, I guess so.
DNA is the genetic code for all life on Earth. There's nothing that doesn't
share ours. It's we share like 90% with banana or something like that.
If we ever found an organism that did it slightly differently, had a different genetic system, that would either be evidence of an alien
nice.
or evidence of a separate origin of life on Earth.
Wow.
Either one would be phenomenal.
Yeah.
Tell you what, I always tell my students, if you find that, you give it to me, and I'll describe it. Give it to me.
I'll put you in the acknowledgments.
Yes.
At all.
I thank my students.
And tell everybody that he or she is my favorite student ever.
Yeah. They'll be at the bottom of the et al. Column there. Okay. Well, that is our show. Lots of beautiful and interesting things that we're exploring and discovering while we're having these conversations. Thank you so much for listening. We will see y'all next week. And this is Science Nights in the Morning. Thanks for listening to this episode of Science Nights in the Morning. Be sure and follow us on Patreon for exclusive gear and uncut episodes. Check out the latest science articles on our Facebook page and subscribe to us on YouTube and your favorite podcast listening app. You can also listen every Saturday at 10 a.m. Central Standard Time at BigBenRadio.com. And if you got a question, we'll join the discussion. Hit the hotline at 432-217-1983 and record your message. We couldn't do this without you, and thank you so much for listening each and every week. That's Science Nights in the Morning with a K, and we'll see you next time.